You are dumb. You can't call yourself a smart light switch just because you have wireless connectivity, okay? Without other sensors, you are nothing. I hope you like the opening. The light switch is located in my bedroom. It's also my workspace. It controls my ceiling light and ceiling fan. I want to automate the light, nothing fancy, just the basics. When I'm in the room, the light will switch on. When I leave the room, the light will go off. When I'm sleeping, the light should stay off until I wake up. These are all my requirements. I think motion sensors like PIR, passive infrared, are not suitable for my case. They are good for detecting motion but not stillness. I'm sitting in the room for quite a long time, therefore I will use a mmWave radar sensor. The light switch already integrated into the Home Assistant. I will make a human presence sensor using mmWave radar sensor to work with the light switch. This is the plan. To make the sensor, I will use ESP32 LD2410C, the mmWave radar sensor, breadboard, jumper wires, USB-C cable, and a power adapter. The LD2410C actually has a Bluetooth capability. I can use Bluetooth to integrate with Home Assistant, but my computer that holds Home Assistant does not have Bluetooth and it plays upstairs. So I will use the ESP32 with Wi-Fi for convenience. I already have Home Assistant and ESPHome installed. If you want to follow this video to build your own human presence sensor, make sure you already have all this software running. Let's start by flashing the ESPHome firmware. Connect the ESP32 to the computer using the USB cable. The ESP32 may need a driver to work properly. Check the board. There may be some information about the USB to UART chip used on your ESP32. Or just ask the seller or check the website you bought it from. My board used the CH340C chip. Use a Chromium-based browser like Edge or Chrome to visit the ESPHome website. Link in description. By the way, I think only the Chromium-based browser support Web USB API. This feature makes flashing ESP32 firmware through the website possible. Select empty ESPHome device, select ESP32, and click connect. The website will ask which serial port to connect to. Select the port connected to the ESP32. If you are not sure which port it is, take a picture of the screen, then unplug the ESP32 and click again. The missing one is the port. Click install ESPHome.web and confirm by clicking the install button. After the installation is done, continue to configure the Wi-Fi connection of the ESP32. Click next. Enter the Wi-Fi credential and click connect, then keep the ESP32 power on. Now go to ESPHome device builder and the ESP32 should appear. You may need to refresh the web page. Click take control. I keep the name as default. You can rename it if you want and continue by clicking take control. After the configuration is created, click install. It will fail and complain about the Wi-Fi part. ESPHome provides an incomplete template. I think it's on purpose. Click edit to fill in the Wi-Fi SSID and password. You can directly put the Wi-Fi credentials here. Another way, here I'm using the secret directive to refer the string in the secret YAML. To use the secrets YAML, close this page, click secrets, then enter the Wi-Fi SSID and password and assign them to the corresponding identifiers. Save it, close it, and click edit, go back to the configuration. I also provide the access point information in case the Wi-Fi fails to connect. To provide a fallback web UI, I also added a captive portal. The rest of the line I just referred to, copy from the ESPHome LD2410 documentation. I only left out the automation and outpin sections. I put a document link in the description. In the UI section, I used the GPIO 17 for TX and GPIO 16 for RX. I also set the baud rate to 256,000. Save the file, close it, validate it first, and then start installing the configuration file through wireless. It will take some time to compile and upload. Okay, the firmware is ready. Now it's time to assemble the LD2410 and the ESP32. Unplug the ESP32. I insert both ESP32 and LD2410 into a mini breadboard to make them easier to use. Connect the sensor TX to the ESP32 RX, labeled as D16 on the board. Sensor RX connects to the ESP32 TX, labeled as D17 on the board. The sensor gets power from the board. The sensor VCC connects to the ESP32 VIN, and the sensor GND connects to the ESP32 GND. Then power the ESP32. Now go to Home Assistant, Settings, Device and Service. Under the Integrations tab, the Discover section should show the ESP32. Click Add, Submit, Select an area, it will be placed in my bedroom, and click finish. It will redirect to the device page. All the readings should display here, which means the hardware assembly is correct. Continue to create the automations. Click the plus button beside the automation section. I will use the device as trigger. When the human presence sensor present reading is occupied, my phone is not in focus mode, and the ceiling light is off. Then switch on the ceiling light. Don't forget to save and give it a name. I also create another opposite automation to switch off the ceiling light. I left the rest as default, it's ready to use now. Let me use this for a few days, then I will come back and tell you the usage experience. A few weeks later, with the help from the human presence sensor, it really makes the light switch a little bit smarter. The automation setup worked as expected most of the time. The human presence sensor detection is mostly accurate. Yup, there are a few catch. It did fix my bad habit of not switching off the ceiling light when I'm not in the room for a long time. Before I fixed the smart light switch issue, I created another issue. It's just like my life. The sensor's default detection distance is too short. When I stand slightly far away, it fails to detect my presence. This happens when I do a little bit of weightlifting. I use the HLK radar tool to adjust the detection distance to fix this problem. But it still doesn't work well when I do plank on the yoga mat. I think it's the placement issue. I should place it higher and tilt it downward to cover the whole room. The human presence sensor is good at capturing still moments like standing and sitting, but sleeping is a little bit of a challenge. So I incorporate it with my iPhone focus mode to stop the automation causing disturbance. When I nap, I turn on the nap focus mode, and sleep mode will auto turn on according to the schedule I set. I use a stand fan in my bedroom, and this is my only way for cooling or ventilations. When you turn on, the human presence sensor sometimes detect it as a person. I'm not sure how to fix that. Maybe I can adjust the sensor gate, make it less sensitive so it doesn't detect. The last issue is with the Z-bit coordinator. Sometimes it's unable to communicate with the smart light switch. The automation runs fine, but the Z-bit coordinator can't find the light switch. I update the firmware on the Z-bit coordinator, that fixed the problem. Okay, final thought. I think human presence sensor alone is not enough. I should also get some seat sensor under my bed for better automation control. I know I can still do more to make it better, adjusting the sensor gate's value, better placement, or setting up zone. For now, I will leave it like this. It works okay and I will upgrade it later. Thanks for watching. Subscribe, like and comment. See you in next video. Bye. Here's an extra. If you haven't watched my previous video, I actually designed and 3D print a case for this human presence sensor. I moved everything from the breadboard into the case. It looks slightly better.